NASA recently launched the Kepler Mission, a large space telescope with the main purpose of finding new planets. Johann Kepler, the scientist who the mission is named after, created his laws of motion, which includes planets move in an ellipse with the sun at one focus. Kepler's laws of motion led to the basic idea of this mission. Kepler will be continuously pointed at a region of space between the constellations Cygnus and Lyra, an area chosen because of the large amount of stars. 100,000 stars will be simultaneously observed over at least 6 years. Kepler will be looking for any signs of planets. The first objective of Kepler is to determine the number of terrestrial and large planets in or around the habitable zone, which is the region around a star that is at the right distance to not be too hot and yet not be so cold that there could be no liquid water. Kepler will look for planets using the concept that if a planet moves in the path between the observer and the star, then the light from the star will be dimmed slightly. The second objective is to determine the size and orbits of these planets. The size can be found by the amount of decrease in light. A large decrease means the planet is large, and a small decrease means the planet is smaller. The length of the orbit is found by the amount of time that the light is dimmed. Another mission of Kepler is to observe the frequency of planets in multiple star systems. Many stars exist as binary stars, and scientists want to observe the effects of having two stars on a planet orbiting them. The fourth objective is to determine the composition of the found planets. Reflectivity, or albedo, the semi-major axis, size, mass, and density of each planet will be observed. The composition of the atmosphere will then be looked at, and this will help to determine if the planet is habitable, such as if water or oxygen is found in the atmosphere. Spectral analysis of the stars that planets do orbit will be observed to find composition, size, density, and type to find if planets orbit a certain type of stars more than others. The use of SIM, Space Interferometry Mission, and Doppler will further the search for planets by looking for planets that do not transit the star. Using all the information gathered will help determine the amount of planets in the galaxy, and then determine the number of planets that could be habitable. This will help scientists determine the volume of space that should be searched for to find life. Kepler will also give a list of confirmed planets for SIM and Doppler to look at instead of looking blindly around the galaxy.
The Kepler telescope uses the transit method of finding planets orbiting stars. This involves observing repeated transits of planets in front of their stars, which causes a slight reduction in the star's apparent magnitude, or brightness as seen from Earth. Here is an example of a planet in transit across a star, and a graph of the brightness of the star as seen by the Kepler telescope. Since the Kepler mission only has a planned lifetime of 3.5 years, most of the planets are being found have a relatively short orbital period. From this observation, several properties of the planet can be found. The reduction in brightness can be used to find the size of the planet. The interval between the transits can tell us how long it takes the planet to orbit its star, and the mass of the star using Kepler's third law of planetary motion. From the orbit of the planet and the temperature of the star, a planet's temperature can be calculated. From this we can conclude if the planet is in a habitable zone around its star, just like Earth is around our Sun. The Kepler telescope is a photometer made up of 42 CCDs. It takes data of 150,000 stars and measures variations in their brightness every 30 minutes. Here is a detailed picture of the important parts to the telescope. The telescope must be space-based to obtain the precision needed to reliably see a planet's transit and to avoid interruptions caused by day and night cycles, seasonal cycles, and atmospheric impurities.
Since its launch in March of 2009, the Kepler mission has located 8 Earth-like planets, although 3 of these planets had already been discovered. The 5 other are new discoveries. The first one is named Kepler 4b. As you can see here, the curve is very small because the curve is in relation to the size of the planet off the amount of light that the sun is emitting. But when you go over to Kepler 5b, it's drastically different. In Kepler 6b, the results are even greater. In Kepler 7b, the results go back to about similar to Kepler 5b. In this picture, you can see Kepler 8b is a tiny dot in a wide picture, which is what the Kepler mission is looking at. Here we have an overall picture of all the transit light curves of the 5 Kepler discoveries. If you look at the bottom, you can see the orbital period in days. Those days mean that for example, for the Kepler 4b, every 3.2 days, you get to see this slight movement in the light flux. And if you look at it enough, then the results can prove that there is a planet there. But when you're looking at planets where the orbital period is a year, like Earth, you might miss these small little changes in flux. Next, we have the planet size. That's another huge factor, because if the planet is so small in comparison to the Sun, you're not going to see it. And as you can see, all the discoveries except for Kepler 4b are larger than Jupiter. Next, we have a graph of all the sizes of the planets, and then you can see Earth inside the habitable planet green strip, and a planet would need to be inside that strip to be able to sustain life. And as you can see, Venus is the closest one, and the Kepler planets are all very far in the distance. Finally, you can see the temperatures of the Kepler planets and the planets we know in our solar system. Earth is in between water freezing and water boiling, and a planet needs to be in between those to be able to sustain life, because as we see it, water is necessary to sustain life.